Assalamualaikum warahmatullahi wabarakatuh, and hi again. In this video, I will share with you the procedure for a statistical test of hypothesis on a difference between the two population proportions pi 1 minus pi 2. Let's proceed to the topics learning objectives in the next slide. Similar to other previous topics, this topic will also focus on the same learning objectives listed as follows. At the end of learning this topic, you should be able to perform a hypothesis test on the difference between two population proportions pi 1 minus pi 2, which is the parameter of interest to be tested this time. Second, you should be able to classify which of the two cases you should use in testing pi 1 minus pi 2. Third, you should be able to identify a suitable test statistic to be used in this topic and calculate the chosen test statistic value. Once you have calculated the test statistic value and compare it with the relevant critical value, you should then be able to achieve the fourth learning objective, which is to make a correct decision whether to reject or not to reject H0, followed by writing a correct practical conclusion about pi 1 minus pi 2. And finally, you should also be able to describe a meaningful comparison between the two population proportions pi 1 and pi 2. For testing the difference between pi 1 and pi 2, we also have three types of hypothesis tests: two-sided, left-sided, and right-sided tests. We look first at case 1, where the value of a difference between pi 1 and pi 2 under H0, which is pi 0, is not 0. That is, pi 0 takes any value other than 0. Recall in chapter 3, we only use a z-score in constructing a confidence interval for pi 1 minus pi 2. Similarly, we will use only a z-test statistic in testing pi 1 against pi 2 in chapter 4. The test criteria related to z-test statistic are all the same as before for the three types of hypothesis tests as listed in the following table. First, the two-sided test where pi 1 minus pi 2 is different from the particular value pi 0 under the alternative hypothesis H1. The corresponding test criterion is reject H0 if the modulus of z-test is greater than z alpha over 2, which can also be expanded into this following expression. Next, the left-sided test where pi 1 minus pi 2 is less than pi 0 under H1. The corresponding test criterion is then reject H0 if z-test statistic is less than the left-sided critical value, which is negative z alpha. And finally, we have a right-sided alternative hypothesis test where pi 1 minus pi 2 is more than pi 0. Therefore, the corresponding test criterion is reject H0 if the z-test statistic is greater than the right-sided critical value, which is z alpha. The test statistic used in this topic should also relate to the parameter being tested. Here, the z-test statistic is defined as the difference between two sample proportions p1 minus p2 minus pi 0, which is the hypothetical value of pi 1 minus pi 2 under H0, divided by the estimated standard error or standard deviation of a sampling distribution for p1 minus p2, which is the square root of p1 times 1 minus p1 over n1 plus p2 times 1 minus p2 over n2. Please note that we do not know the actual value of individual pi 1 and pi 2. What we know under H0 is only the value of a difference between pi 1 and pi 2, which is pi 0. Therefore, we need to estimate the individual parameters pi 1 and pi 2 in the z-test formula by p1 and p2 respectively. Let's look at case 2, where the value of a difference between pi 1 and pi 2, that is pi naught, is 0 under h naught. The three types of hypothesis tests are listed as follows. Notice that the test criteria are still the same as in the previous slide. However, when we have pi 1 minus pi 2 is equal to 0, then we will have pi 1 is equal to pi 2 under h naught for all three types of hypothesis tests. Whereas under h1, we either have pi 1 is different from pi 2, or pi 1 is less than pi 2, or pi 1 is more than pi 2. Notice also that we still use a z-test statistic, but now its definition is modified by taking into consideration that we actually have the assumption of equality of proportions under h naught, where pi 1 is equal to pi 2. In such a case, the modified z-test statistic is given by z-test equal to the difference between the two sample proportions p1 minus p2 minus 0, which is the value of the difference between pi 1 and pi 2 under h naught, divided by the square root of p sub p times 1 minus p sub p times 1 over n1 plus 1 over n2, where the notation p sub p is defined as the total number of successes or failures denoted by x1 plus x2 divided by the total sample size n1 plus n2, which is what we call a pool or weighted proportion. For your information, this formula is given in the statistical table booklet, page 3. Please look at this example. For the first illustration, a company supervisor has observed that two machines A and B have different capability and claimed that the difference between the percentages of defective items produced by machines A and B could be more than 2%. He took a random sample of 200 items produced by machine A and 250 items produced by machine B and found that 21 from machine A and 9 from machine B were defective. Test at alpha equal to 0.05 whether the sample data provide any evidence to support the supervisor's claim. From the question, we can recognize the following information. Suppose 1 denotes information from machine A and 2 from machine B. From machine A, we have a sample of size 200 and the number of defective items produced is 21. So, in notations, we have N1 equal to 200, X1, which is the number of defective items produced by machine A, is 21, and hence the sample proportion of defective items produced by machine A is 21 over 200, given by 0.105. Similarly, from machine B, we have the sample size 250. The number of defective items produced is 9, so in notations we have N2, X2, and hence P2, which is the sample proportion of defective items from machine B given by X2 over N2, which is 0.036. In this question, we want to test if the sample data provide any evidence to support the supervisor's claim. What is the claim? The supervisor claimed that the difference between the percentages of defective items produced by machine A and B could be more than 2%. As we know, percentages or fractions can be turned into proportion values from 0 to 1. Hence, in this question, we are to test if pi 1 minus pi 2, which is the difference between the proportions of defective items produced by machines A and B, is more than 0.02. Therefore, the parameter of interest in this question is clearly pi 1 minus pi 2. Furthermore, the difference in the two proportions that we want to test here have a value of 0.02 or 2%, which is apparently not zero. This is consequently case 1, where we will use a z-test statistic with P1 and P2 in the z-test formula to estimate the individual population proportions of defective items by 1 and by 2 respectively. Here, we have a right-sided alternative hypothesis test that should be performed at 5% or 0.05 level of significance, which is further illustrated in the next slide. From the previous slide, we already knew that in this example we have a right-sided alternative hypothesis. Therefore, under H0 we have pi1 minus pi2 equal to 0.02, and under H1 pi1 minus pi2 is greater than 0.02, which is exactly the supervisor's claim. The rejection rule is then reject H0 if z-test is greater than z 0.05, which is 1.6449. Since we have a value of 0.02 under the null hypothesis H0, then we have case 1 where we will use P1 and P2 in the test statistic defined as follows. You may check that the value of z-test statistic in this example question is 1.9861. What can we decide then? By comparing the z-test value and the right-sided critical value, we can see that the z-test value is greater than 1.6449. Hence, we can decide to reject the null hypothesis H0 in favor of the alternative hypothesis H1 and conclude that the sample data provide a strong evidence at the level of significance alpha equal to 0.05 to support the supervisor's claim that the difference between the percentages of defective items produced by machine A and machine B is more than 0.02 or 2%. For the second example in this video, please refer to task 4.11 on page 103 in the Statistics for Engineers textbook. As usual, we do have a number of information in the question that we should recognize, extract, and write the information using correct notations. From the sample data, let 1 denotes information from UTM students and 2 denotes information from UKM students. Here, we have 150 UTM students, where 102 of them were in favor of the new grading system. Therefore, in terms of notations, we have N1 equal to 150 and X1 equal to 102, which gives us the sample proportion of UTM students who were in favor of the new grading system to be 102 divided by 150 given by 0.68. Similarly, we have 180 UKM students, where 108 of them were in favor of the new grading system. In notations, we have N2 and X2, which lead to the second sample proportion P2, which is the sample proportion of UKM students who were in favor of the new grading system given by 0.6. Having identified this information, we need to ask what parameter we want to test. If we look at the question again, we want to investigate if the survey results indicate a significant difference in the proportions of UTM and UKM students who favor the new grading system. In short, we want to test if pi1 is different from pi2 or pi1 minus pi2 is different from 0, right? Therefore, the parameter of interest is clearly pi1 minus pi2. In addition, the value of a difference between pi1 and pi2 is 0, indicating that pi1 is equal to pi2 under H0. Therefore, we have case 2, where we will use a z-test statistic with the pool proportion in the z-test formula, where this pool proportion is used to estimate the unknown and equal population proportions. In this task question, we have a two-sided alternative hypothesis test that will be performed at the level of significance alpha equal to 0.01. Let's look at the complete solution in the following slide. As we have a two-sided alternative hypothesis test for this task question, then under H0 we have pi1 is equal to pi2, that is pi1 minus pi2 is equal to 0, whereas under H1 we have pi1 is different from pi2, that is pi1 minus pi2 is different from 0. Since we have a two-sided alternative hypothesis test, the rejection or decision rule is then reject H0 if the modulus of z-test is greater than z alpha over 2, which is z 0.005 given by 2.5758. How are we going to define the z-test? If you look at the null hypothesis H0 again, the value of a difference between the population proportions is 0, which indicates that we have an equality of population proportions under H0. Therefore, we have case 2 here where we will use a pool proportion in the z-test formula to estimate the unknown and yet equal population proportions, where the pool proportion is given by x1 plus x2 divided by n1 plus n2. Substituting this formula with the corresponding values, we have a pool proportion to be 0.6364. Now, we can calculate the z-test statistic by using this formula. You may want to calculate the value of z-test statistic on your own and check if you get 1.5043. Now, you can compare the modulus of z-test value with the critical value. Obviously, the modulus of z-test is smaller than the critical value 2.5758. Therefore, we fail to reject H0 and conclude that the sample data from the survey results do not provide any strong evidence at the level of significance alpha equal to 0.01 that the proportions of UTM and UKM students who were in favor of the new grading systems are significantly different. In short, pi1 is not different from pi2 at alpha equal to 0.01. Having done two examples on testing the difference between two population proportions, we are now at the end of this session. Before ending this session, let us look again at this topic, learning objectives. Hopefully, after truly and honestly learning this topic, you may question yourselves whether or not you are able to achieve the following 5 objectives. First, are you able to perform a hypothesis test on the difference between two population proportions, pi1 minus pi2, which is the parameter of interest in this topic? Please remember that you do not test the difference in two sample proportions, p1 minus p2. So please be careful with the notations. Second, are you able to classify the two cases on testing pi1 minus pi2? The two cases depend on the value of a difference between the two proportions under the null hypothesis H0. Case 1 is when the difference is not 0, so you should use individual sample proportions P1 and P2 to estimate the individual population proportions pi1 and pi2 respectively in the z-test formula. Whereas we have case 2 when the difference between pi1 and pi2 is 0 under H0. In this case 2, you should use a pool proportion to estimate the unknown and equal population proportions in the z-test formula. Next, are you able to achieve the third objective, which is to identify the suitable test statistic and calculate its value correctly? Again, this third learning objective is related to the second objective. Although we have two cases, we only use a z-test statistic in testing the difference between two population proportions. We do not use other test statistics like t-test or chi-square test or f-test. But again, please choose the correct z-test formula either from case 1 or from case 2. Next, are you able to make a statistical decision correctly and write a practical conclusion about pi 1 minus pi 2? And finally, are you able to describe a meaningful comparison between the two population proportions? Again, by just listening to this video is not sufficient. Please do a lot of exercises and practice to solve more questions in order to gain a better insight on this topic. Feel free to contact me if you have any inquiries. Until then, Assalamualaikum warahmatullahi wabarakatuh and thank you for watching.